Hi, my name is Lucas Wentro, and today we're going to be memorizing the unit circle. I'm going to talk about a trick to memorize all the values for the unit circle that doesn't require any math, but before I explain that, I'm just going to briefly go over some of the underlying math and the equations so that if you ever want to check your reasoning, you can always think back to these explanations that I gave. Before I get into it, this trick came from Viper Girl 89 on YouTube, so if you want to see the original video, you can go check that out. So, in the unit circle, which is a circle of length 1, there are thirds, quarters, and sixths. And you're going to have to memorize values from each of these parts. And first, we're going to look at thirds. So the thirds are going to be angles where the denominator is over 3. And here is 1 pi, this region shaded in yellow, c pi, that's 1 pi, and we split up into 3. So this is going to be 1 pi over 3, 2 pi over 3, 3 pi over 3, otherwise known as pi. This is 4 pi over 3 right here. And this is 5 pi over 3. And then this is going to be 6 pi over 3, otherwise 2 pi, but 2 pi is the same as 0 because we've made one circle. Now the values here for this point, the x and the y coordinates, are going to be 1/2 and square root of 3 over 2. If you wanted to find that yourself, you could just see that this is 60 degrees because this whole thing is 180 and this is a third of that, so that's going to be 60. That means this angle is 30 degrees because this is 90. And then you can use your 30, 60, 90 rules and the fact that this is length 1 to get these values here. Now, you don't have to memorize these, only that you only have to memorize these values here, and then just if it's going in whichever direction, make it positive or negative. Like for example, this one down here, this is negative for both because it's in the negative x direction and the negative y direction, aka left and down. Now let's look at quarters. So each of these parts shaded in red are 1/4. So this is going to be 1 pi over 4, 2 pi over 4, otherwise pi over 2. This is 3 pi over 4, 4 pi over 4, otherwise known as pi. 5 pi over 4, 6 pi over 4, otherwise known as 3 pi over 2. 7 pi over 4, and 8 pi over 4, which is also 2 pi, which is also 0. To find the coordinates of this, you could just see that this is 45 degrees. This is also 45 degrees, and the reason for that is because this is a quarter of 180 degrees, so this is going to be 45, and then you can use your 45, 45, 90 right triangle rules, and the fact that this is length 1 to get that these values here are root 2 over 2. If you do the math for that, you might first get that it's 1 over root 2, but if you simplify and get no radical in the denominator, then you'll end up with these values. Now let's look at sixths. So this is related to thirds because 6 is just half of thirds. And so I have highlighted in yellow the stuff that we already went over. And it actually looks really similar. So these are the values of the 6. So it goes from 0 pi over 6 to pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi, 5 pi, 6, and so on. Now the values for these coordinates right here, like the x and the y, look just like the values for pi over 3, but they're just flip-flopped. And the reason why is because it looks like these two values just were flip-flopped like that, and they are. In fact, this angle right here, because it's 1/6, this is 30 degrees, and this is 60 degrees, and this is 90. And earlier, we saw that we had another triangle, which is the same thing, but just rotated. So that's why the values are flip-flopped. So all you have to remember for the pi over 6 values is that x is longer. It's going to be 3 pi over 2, which is bigger than 1/2. Or not 3 pi, square root of 3 over 2, and then 1/2. And that's because you can tell that this x length is longer than this one, and so the 1/2 is going to be the y. Also, if you draw a line right here, it also looks like 1/2, split into two parts. So the height looks like it's 1/2 of the circle. So now that you know the context for the unit circle, now we can move on to the trick. that requires no math. So I have this empty unit circle here, and after I explain the trick, I recommend that you come back to this point and just attempt it yourself. And now I'm just going to show you how it works. So this, I'm going to fill out the multiples of pi over 2, which are right here. So this is 0 degrees, or 0 radians, and this is going to have a coordinate of 1, 0, because this is a unit circle. This is pi over 2, because this is a quarter, of course, and the whole thing is 2 pi, so a quarter of that is going to be pi over 2. This has an x coordinate of 0 and a height of 1. This is pi radians, and then right here is going to be -1, 0, and then this is 3 pi over 2, and then right here is going to be 0, -1. Alright, so now moving on to the more important things, the harder stuff. You're going to have to memorize the angles and then the points. And then after you memorize the points, then you can do things like cosine, sine, and tangent, which I'll show you later. First, we're going to do the angles. So here, it goes from big to small. So everything here has pi on top. So pi, 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 pi. And then it goes from big to small going up. So 6, 4, 3. It's also the same over here. It's going to be going up, it gets smaller. So 6, 4, 3. And it's actually, as you get closer to the x, so to the x axis, as you get closer this way, then the numbers get bigger. So this is also going to be 6, and then as you get away, it's going to get smaller. So this is 6, 4, 3, and this is also going closer to here. It's going to be bigger. So this is going to be 6, 4, 3. So those are the denominators for all of those things. Now this region is just pi on top. This is going to be pi times 1 less than the denominator. And so what I mean by that is like this. So the denominators are, of course, 6, 4, and 3. And so then the top is going to be 5, 3, 2. Because 6 minus 1 is 5, 4 minus 1 is 3, and 3 minus 1 is 2. So it's just going to be 1 less. So you can consider this the -1 region. This would make this the pi region. Now here, this is the +1 region. So on top, you'd have 1 more. So then you have 7 pi over 6, 5 pi over 4, and 4 pi over 3. Because it's going to be 1 more than the denominator. So like 6 plus 1 is 7, 4 plus 1 is 5, and 3 plus 1 is 4. Now, this is just an odd sequence. This is going to be 5, 7, 11. So 5, 7, 11. And since these are odd numbers and it's a weird sequence, weird is odd. So that's one way to remember. So those are all the angles. And now we can move on to the coordinates. So everything is going to be over 2. So it's going to be like basically a half times something. So this is going to be over 2, over 2, over 2, over 2, over 2. And we don't really, all the numbers for all the quadrants are going to be the same except the sign. It's just going to be like positive or negative or plus minus, all that. Just depends on which quadrant, because it depends on the direction. So what we're going to do is just this little trick. It's kind of like the numbers, where it goes ascending, descending for the angles. It's the same for this, but instead, it's going to go like square roots. So this is going to be square root of 1/2, square root of 2, and square root of 3. And then so 1, 2, 3, and then this is going to go 1, 2, 3 going up. So you have 1, 2, 3, and then 3, 2, 1. If you wanted to look at it here, this is square root of 0. So it does go like 0, 1, 2, 3, and then 4. Or square root of 4 over 2 is the same as 1. So it does go from like 0, 1, 2, 3, 4. And then the y is just the opposite. So it's going to be instead going this way, 4, 3, 2, 1. Don't forget that square root of 1 is 1, so that's why we have 1/2 written instead. And also, let's see, so for this point, pi over 3, the coordinates of that are 1/2 and root 3 over 2. The x-coordinate definitely looks like 1/2. See, this is 1 and 1, so split in 2. And also square root of 3 over 2 is probably like 0.7, roughly. And the height of this looks like looks like 0.7 about, maybe I'm lying, but it is more than 1/2, so that's why it's higher. And also pi over 2, square root of 2 over comma square root of 2, it looks like that because this is the pi over 4, the quarters, split it just down the middle in a perfect diagonal. So that means that on either side of the diagonal, it's going to be the same because it's cut down right there. And so that's why it looks the same. It kind of makes this like a little square. So now, to do all the rest of these coordinates, you just do plus or minus. So this region is going to have coordinates with a sign of minus and plus, because this is going in the negative direction for x, which is left, but it's still going up, which is positive. So instead we have negative 1/2 and positive root 3, negative root 2 over 2, negative root 2 over 2, and then root 2 over 2. And lastly, negative root 3 over 2, and then 1/2. And so you can fill the rest out if you wanted to, knowing that the coordinates here are going to be minus minus because it's going down and left. And the coordinates here are going to be plus minus because it's going down but right, and right is positive and down is negative. So it's just going to be all the reflections. So these points will match up but have different signs. These points match up. These points match up. Same thing with this. It's all symmetrical, which is nice because, you know, it's a circle and a circle has all these like pretty symmetries. And this ends up being really useful for a lot of things. And now if you wanted to do the cosine and sine of these values, it's actually super simple. So the cosine of theta, and let's say it's pi over 3. The cosine is going to be the x-coordinate, so 1/2, and the sine is going to be the y-coordinate, so sine of pi over 3 is going to be root 3 over 2. And the theta right here is pi over 3. And the reason why is because cosine of theta is adjacent over a hypotenuse, but the hypotenuse of this circle is the radius. See, this is the hypotenuse, and the radius is 1. So it's just cosine theta is equal to adjacent, and the adjacent side of this triangle right here is x. So cosine of theta is x, or 1/2. And then sine, you get, doing the same math, you'll get that sine is equal to opposite, which is equal to y, like this. And so for any of these, like for example, cosine of 11 pi over 6, the coordinates of that is square root 3 over 2, 1/2. That, you just take the x-coordinate, so it's going to be root 3 over 2, and then sine of 11 pi over 6 is going to be negative 1/2. Now tangent is really similar. It has all these nice symmetries as well, but it just has slightly different numbers. So tangent is gonna, if you work it out with, tangent is opposite over adjacent, and we already got that opposite is going to be y, adjacent is x, and so it's going to be the slope of the line. And for, let's say, pi over 3, again, it would be root 3 over 2 times the reciprocal of x, because you're dividing by x, so you just flip it. So the times 2. So that means this is root 3. So tangent of pi over 3 is root 3. Now tangent of pi over 6, which is the flipped one, is just going to be this answer flipped. So tangent of pi over 6 is 1 over root 3, which is the same as root 3 over 3. So if I were to just put the tangents here, it would be this and that. And you could also just do the math if you wanted to. And also the tangent for this, pi over 4, is going to be 1, because it's the slope of something with, like with where the numbers are equal, it's going to be 1. Because pi over 2, something divided by itself is going to be 1. Now, the slope of the tangent of this, or the slope of this line that goes straight up, is undefined, because you could think that the slope is infinity or negative infinity, because it could be going infinitely that way or infinitely this way. So that's why the tangent of this is also undefined. The tangent of this is 0, because 0 divided by anything is 0. But anything divided by 0, like this, 1 over 0, is going to be 0. Or not 0, it's going to be undefined. And then here, the tangent of this is also going to be 0, because it's flat. And now, for the tangents of these, you just do the negative again, because it's flipped this way, so now the slope is facing down. So it's the same value, but just negative. And this is going to be negative 1, and this is going to be negative root 3. And then this coordinate has the same slope as these lines. These are also positive. So the tangents of this will have the same as the lines that go straight through it. So like that. So this one has a tangent of root 3, because this is the same line as the line that has a tangent of root 3. So that's why these ones are the same. And these ones are also root 3 over 3, because they're the same line and they have the same slope. So I recommend that you go back and try this all yourself. If you practice it, you should be able to do it in less than 5 minutes. And I hope that helped you, and you don't have to think as much when you do it. Just remember that, when the numbers go up and when they go down, and when to use pi and the roots and all that stuff. And it's not that complicated if you just go off the simple rules, and then you can check yourself with the stuff that we talked about here. So now I hope that memorizing the unit circle is a lot easier.